Okay, hello everyone. Welcome to our second webinar organized by Automat-IT and AWS Kyiv user group. Today we will talk about MLOps and LLMOps, hot topics out there right now. So we will try to dive deeper and understand what do they mean and how are they actually related to each other. I am Vladyslav Melnyk. I will be your presenter today. This will be a session based on AWS grading. It's 200, so it's a foundational session, but some technical background is still required. But we will try to be quite detailed and start from the foundations. Before I begin, few words about our company and what we are doing. In Automat-IT, we are AWS premier tier partner. We have also a lot of competencies validated by AWS. And also we have many certified engineers. And basically this company really puts a big focus on knowledge and learning. So like going into certifications and all this learning all these new technologies within AWS is highly appreciated in our company. Our main capabilities and expertise is in DevOps, but also we do FinOps and MLOps. We have a lot of experts that are very experienced in providing CI/CD pipelines, AI ML projects, Gen AI projects, security, and also we have a lot of experience with Kubernetes. We delivered more than 500 customer launches and projects, several projects related to Gen AI. So we are helping our customers to build systems based on large language models, including LLMOps, but also topics like RAG. You can access our website and see our previous webcasts about these topics as well. And moving forward, few words about myself. So I am a senior MLOps engineer. I have around 9 years of experience in machine learning and data science engineering, mainly machine learning, engineering, computer vision, MLOps, and things like that, but also a bit of a data science as well. I finished a master's degree in computer engineering in Lviv Polytechnic University. And I took part in, I can say, all the stages of machine learning lifecycle. And also I am AWS certified engineer. Except my job, I'm a big fan of football. I like traveling, I like mountains, skiing, and also AI is one of my hobbies as well. So now let's go into the topic. And briefly about the agenda today. By the way, we will have a small presence in the form of AWS Cloud credits for you. So please, if you're interested, be active in the chat or in the Q&A session after the presentation, and we will be providing those credits to the most active participants today. And our agenda includes MLOps recap. So we will discuss, how MLOps appeared, why does it exist, and what does it mean. Then we will compare it with LLMOps based on Amazon SageMaker examples. However, the idea is pretty much the same on any cloud provider. We will talk about these new capabilities or new ways of working that large language models or Gen AI brought to us, including prompt engineering and fine-tuning. And we will also provide a very simple LLMOps architecture example on AWS and tell you how it works and how you can start training or fine-tuning your own large language models. We'll share all the resources and some learning materials that we think will be very useful if you want to if you want to start learning about MLOps and LLMOps, and at the end we will have a Q&A session. So let's start, and let's begin with the history of why MLOps even is in the picture right now. I know there are a lot of DevOps engineers in participants today, so I will be referring to DevOps a little bit as well. So you know that any kind of operation problem is the intersection between people, process, and technology. Here you can see MLOps in the middle, but it can be any other word like DevOps or LLMOps as well. And all the kind of operation problems, they are related to people, processes that they follow, and technologies that they use. So when it comes to people, a few years ago, I would say around 10 years ago, data science was kind of boom like Gen AI right now. And there were a lot of data scientists that started working for like a lot of big companies and trying to bring value out of the huge amount of data that grown through the past years a lot. And basically, these people are mainly scientists. Yeah, they are not engineers. Some data scientists are engineers, but this is not mandatory and this is not the primary requirement for them. They need to be able to explore the data very well. They need to be able to apply different data science and machine learning algorithms to solve ML AI problems, but they are not necessarily the best engineers. And this led to, a lot of companies invested a lot into the data science. And with time, they wanted to have real value out of it, right? So they started planning production for data science use cases. And this is where we hit the process challenge, because yeah, a lot of people were aware of like typical software development lifecycle, where DevOps is which is served by DevOps, but some processes there do not always align with the machine learning development lifecycle, because there are new artifacts, there are new requirements for this to make work data science work like production ready or good to be deployed. That's why new technology appeared to follow that. So new technologies, new tools that will be help to deploy and maintain models in production, make sure that they are reliable and things like that. And then the existing stack, DevOps stack, wasn't enough to cover that. So moving to the next slide, you probably have seen the similar illustration of a DevOps process, where we have the infinite loop, and this infinite loop starts with planning. So basically, every use case should be planned, right? And there is there must be a value in it before it can go into production, into operations. So this is what I meant by data scientists. They proved that there is a huge value in data science, machine learning, and AI. And then there was a create phase where we decide to move those models into production. And the main artifacts here, like compared to DevOps, where we had code mainly, we have data and model, because data is very important in this case, because the model quality fully depends on the data quality you have. So if you have no data, or you have no data with a good quality, there is no way to move to the next stage and build a proper model on top of that. After you have a proper data, you can build your model. Once you build your model, the nature of models is pretty difficult. So there are terms like overfitting, when the model learns all your data and then it performs very badly on the new data. There are terms like optimizations, latency, and things like that. So we need to verify the model, and verifying the model here means a lot. So it's kind of model evaluation in one phase, a model data quality, and things like that. Then we have to package the model. So the rest of the cycle is pretty much similar to the DevOps. So after we are sure that this model is in good quality and we really want to have it in production, we want to release it. Once we release it and configure it to work on production, we must monitor it, because the model can reduce quality over time. The model the surrounding environment where the model is deployed can also change over time. The data can change, so we need to monitor all of that. And once those changes are detected, we need to start the cycle again. We need to probably recreate the data or the model, verify, package, and release. So this is a similar loop to DevOps, but with a bit of, let's say, special parts that are related to the model and the data. Then, when talking about MLOps, it's also important to mention that there is a term or a kind of grading system that is called MLOps maturity levels. There are different ways on. There are different providers, and these different providers share different grading systems. It can be said like from 0 to 4, but AWS provides a bit more detailed explanation to this. So initial phase, it's when you only start experimenting. It's when you have a data science, you have some kind of environment where they can quickly experiment, test new models, and they don't have to follow some kind of code quality rules. They don't have to follow clean code and things like that. I see that the hand is raised, so I just have to mention that please wait till the end of the session, and we will have a Q&A session where we will answer all your questions, and I won't be interrupting during the webcast. So the next phase is called repeatable according to AWS. This is when you already have several models, they bring in value, and you want to move them into production. When you want to move models into production, you need to standardize the code, you need to decouple repositories, and we need to create deployments. Like it can be, CI/CD for the model, for the model training code, for the model serving code. It can be some kind of standardization that helps you to release those models faster in a way that you want, either as an APIs or some batch jobs and things like that. But you don't necessarily, you still want to run fast. You don't have that many models. And the next phase is actually covering these points. So, when you have a very, very important system, you have a lot of customers that are using this system, you must follow some of the standard quality, software quality rules, and you need to introduce testing. You need to introduce monitoring. So in this case, testing, it can be stress testing, volume stress testing of your model. It can be unit testing of the serving code, for example. Monitoring. So monitoring, in this case, this involves either infrastructure monitoring, where you make sure that you have reliable and scalable infrastructure that can host your model reliably, so that customers will always get answers and there won't be unexpected behaviors. But also, as I mentioned, in ML there are other types of monitoring called model monitoring or data drift monitoring, where you build a system which will basically constantly check your model predictions and the data that is incoming to your model, to understand that it's following the same quality that you initially had. And if something goes wrong, you need to retrain the model, or you need to change the data set and things like that. And multi-account deployment, because in the reliable phase, it's super important to focus on security as well. When you have customers, you need to focus on security, and multi-account approach is a secure, governed way in order to provide high quality machine learning models. And scalable maturity level, it's when you have many projects that are already reliable. You have many projects for different AI tasks. So let's say several NLP projects, several computer vision projects, tabular data science projects, and things like that. And you can see some similarities between them. You can see that you can templatize some pieces of this process, and then you can, when you have a scalable maturity level, you can deploy and you can start new projects much faster compared to if you are on lower maturity level. So this is about the maturity levels of MLOps, and our talk will be something in between repeatable and reliable. In order to understand MLOps and why is it needed, or what it does, it's really important to understand the entire machine learning life cycle. So basically, what happens since the idea to when the model is in production, and we can say that the model is that we apply MLOps to it. Everything starts with the data, as I already mentioned. Data is in the red color here, because this is an important point. And if you don't have data, if you don't have data in a good quality, of course there are some techniques that you can perform. You can upscale your data, you can clean up your data, you can apply some synthetic data generation. But if you don't have enough data, these techniques may not lead to the best results. The next step is the data preprocessing. So usually the model requires data in different models require data in different formats. This is something that in data science we can call also exploratory data analysis. After we understand what features or what features our model needs to perform the best on the best level. This is also called feature engineering. After this is defined, we can start the next phase, which is called modeling. So modeling, this is a generic name. This basically includes the model includes all the steps that are required for your model to be operational, for your model to be useful. So first of all, you need to train your model. You need to evaluate your model, and it's also very important to track. So usually this is something you do several times. You want to be able to replicate your previous trainings. You want to be able to log details of your trainings, the model training metrics, let's say this model evaluation results. So you are sure that your model quality is on a decent level, that you can register it in the model registry, and basically move to the next phase, where you deploy this model and serve this model for your customers or for some internal needs. This is the next step where we deploy our model. Here we are saying model endpoint, but it can be not only model endpoint. It can be an edge deployment where we deploy the model to some specific device. It can be also batch processing, where we take a big batch of the data and we process it at once and provide the results. So this is all this is all decided on the model deployment stage. And after that, we have model monitoring. So this life cycle never ends. And we have a model monitoring where we need to ensure that our model stays in this defined quality that we expect to have. So we will have some like data drift, model drift, detection here. And once something happens, once something wrong happens, we will either update our model, maybe architecture of the model changed, maybe there is a new architecture that can handle our task much better, or the data changed. So let's say COVID example, right? We build a lot of models, and then people behavior suddenly changed. Yes, in outside, for example, and a lot of people had to recollect the data and retrain their models on the new data to be reliable again. So this is how machine learning lifecycle looks like. And as you can see, there are roles here that are involved. And from here, you can see where is the main MLOps part. So basically, first we have data. We have a collaboration between data engineers and data scientists. This collaboration involves preparing the data and training the model mainly. After we know that the model is ready, we have collaboration between data science and MLOps engineer. This collaboration usually involves taking the work from data scientists, cleaning it up, writing maybe cleaner code, and then providing the infrastructure and all the tools that are needed in order to build this model, package this model, and release it to production and monitor it. So basically, this is the main responsibility of machine learning or MLOps engineers in this machine learning lifecycle. As I already mentioned, we will be talking about Amazon. We will be talking about Amazon examples and how AWS, Amazon Web Services, provide us capabilities to build machine learning lifecycle. So there is a service that is called Amazon SageMaker, and this is an end-to-end machine learning platform. This is not only a platform that allows to work with LLMs on AWS. It's worth to mention, but we will be focusing only on Amazon SageMaker during this talk. We will not be talking about other services that are available in AWS. The reason for that is that the other services are serverless, and there you don't have to worry about the ops part. So Amazon SageMaker, and this is a great platform that allows to build machine learning products end to end. So this platform kind of serves entire machine learning lifecycle that we've seen on the previous slide. Inside this platform, we can get a lot of examples, pre-built Jupyter notebooks with examples for common problems, like I already mentioned, NLP, computer vision, different pre-built algorithms that you can use. So, for example, for classical machine learning, it can be XGBoost, which is very known, and also you have estimators in SageMaker. So estimators is a kind of helper class that allows you to package your model to be able to use it in Amazon SageMaker. And you can package models from various, or I would say any frameworks, any machine learning frameworks. If you know about them, the most popular ones are PyTorch, TensorFlow, and MXNet, for example. So all of that is supported. Then you can set up and manage different environments for your models. So different models require different dependencies, and all of that you can manage and version your. You can share environments between your colleagues so that they can work on the same or similar models inside this platform. Optimization. So there is a way to trace and profile. There is a SageMaker profiler. Then there are tools like SageMaker experiments, the SageMaker model registry that allows you to monitor your model quality, make sure that model quality is on the desired level, model evaluation results are good, metrics are good, and you can automate all of this using SageMaker pipelines, and you can have, after that, you can have one-click deployments. So basically, after your model is trained, you can deploy it to your AWS infrastructure. And it's also worth to mention that SageMaker is fully integrated into other services, so you can apply auto scaling, you can apply, you can monitor it using famous AWS services like CloudWatch. You can create alerts, and you can apply very tight security using private networks and things like that. So SageMaker is really end-to-end machine learning platform that is really powerful and has a lot of compute. And even this platform basically can serve any type of machine learning models. Also, inside this platform, there is a service called SageMaker Jumpstart that allows you to access foundational models and large language models as well. So let's see how classic MLOps process will look like on AWS. As I mentioned, MLOps is about the collaboration of data scientists and machine learning engineers or MLOps engineers. And as you know, data scientists, they really like working with notebooks. They want to experiment fast. They want to deliver some results quickly, evaluate them, and see if this brings real value. And after the real value is visible, after they perform a number of experiments, they want to move it into production. And in Amazon, there is a way to build automated pipelines using Amazon SageMaker pipeline service. So if we are working within Amazon, typically data scientists will hand over their job in the form of Jupyter notebooks, or sometimes GitHub project, like any kind of projects, code projects that machine learning engineers will have to optimize, add some CI/CD to it, and split and decouple the work of the data scientist into this machine learning lifecycle stages. So they will have to, usually notebook will have everything in one, and the data scientist, machine learning engineer will have to split it into pre-processing, training, evaluation, and model registration steps. In order to be able to automate this is a must, because then it will be a monolith that will be hard to manage. And after the model is registered, there is a service called SageMaker Model Registry. This is a very important service. So basically, you can think of it as a central storage for your models, where you can access your model. You can see which model is used by whom, and where it is used, what are some quality metrics of this model, what were the evaluation results, and also you can version those models. So for example, accidentally some bad model came into model registry and was automatically deployed. You can revert those. You can revert that using SageMaker Model Registry, and you can just reject the model, and it will be automatically the previous approved model will be automatically redeployed. So this is a very important service called Model Registry. The next step, as I mentioned as well, is deployment. The good practice for deployment, before moving anything to production, it's always a good practice to test it. And we call this testing environment. We can call this a stage environment. Depends on who wants to, who uses which terms. But this is where we test our model. When, as I mentioned, we apply this testing, unit testing, stress testing, and maybe some A/B testing to see if the model performs better than the previous version of the model. And when we are sure that the quality is good enough, we deploy it to production. And when the model is in production, it can be used by users. It can be used by our users, right? And this can be in the form of API, edge devices, batch processing, streaming, and things like that. So this is how MLOps works, and this is an example of AWS. But overall, the process will be this is basically serving the machine learning lifecycle. So this process will be the same in any other cloud. But our topic is also about LLMOps, so I believe you're already like this guy in the middle, looking forward to hear about LLMOps. So let's talk about it. But before, let's try to understand how this generative AI boom changed the way we work. We, I mean, these people that were part of the machine learning lifecycle. So in this case, generative AI changed a bit the game, because large language models are very heavy. Yeah, we all know that they weigh a lot. They are really hard to train. They require huge amounts of data to be trained. And this is not that easy for, let's say, small software houses or startups to train those models from scratch. So we will have actors called providers. So these are the companies that have a lot of compute power. They have a very strong data science experts, NLP experts that can dive very deep into details of machine learning models and their architecture. They can design new architectures, and they need also a big squad of labelers or data annotators, because those, as I mentioned, those large language models or generative AI models, they need huge amount of data to be able to be trained. So it will be really hard to compete with them, but also there is something called fine-tuning, right? And this is a not new term. Fine-tuning of LLMs is a bit different than fine-tuning of classic machine learning models, but idea is pretty similar. So we take a pre-trained model or base model from open source or from some of the providers, and we train it on a much smaller much smaller data in order to perform the task that we are interested in. So let's say that base models will be these pre-trained base models. They will be pretty generic, and they are trained to perform many tasks. And in this case, we want to focus these models to focus on some specific problem. So these fine-tuners, and I believe this is where where software houses and not these monsters like Amazon or Facebook will play the role. So fine-tuners will be able to take those models from open source or from providers and fine-tune them on their data. So why am I explaining this? Because it really it kind of relates a lot to what I already said about machine learning lifecycle. Yes, so providers and fine-tuners, they will still have to follow machine learning lifecycle. They still have to make sure the data quality, the model training, and model deployment, so that their models can be used by others, right? So, for example, now a lot of people use like managed services like Amazon Bedrock or OpenAI, right, platform. And in this case, these people, they don't really prepare the data, they don't really train the model, they just take it and use it. So these people are called consumers. And basically, consumers are those who consume those models in a form of APIs or in a form of managed platforms, serverless services, and no real ML expertise is required there. There is a need to understand foundations. There is a need to be able to, understand what you want from the model. You need to be able to phrase your AI task properly. but you don't have to know how to train the model from scratch, what algorithms to apply, or even change the model architecture yourself. So for those people, it will be super convenient to use APIs. And basically here we are saying that no MLOps is required, no LLMOps is required, because here you take the model as an API and you package it as an application. So DevOps and application development practices will be applied more for these actors, consumer actors. So now let's see how LLMOps would look like on AWS using Amazon SageMaker. And you can see there are not so many changes. Basically, they are highlighted in blue here. So we still have data scientists, those that have deep expertise, but we can also have fine-tuners here or prompt engineers here. And these are basically those people that will take the models as well. They will experiment with different models. They will apply apply some experiments to make sure that the model can solve the task that we want it to solve. And once it's a decent model, we want to move it into production, and very similar cycle starts. So we hand over this to machine learning engineers or MLOps engineers. We split this into several stages, like data preprocessing, fine-tuning, or sometimes we don't need to fine-tune the model if the base foundational model or base pre-trained model is able to perform our task on the decent level without training on our data. But we still want to evaluate it, right? So this is how we will know if this model is actually satisfying our needs. And we need to register this model. We also want to, if we are fine-tuners or providers, we definitely want to register this model, monitor this model, and version this model so that we can have control over it. And then we have a deployment phase, which is pretty much the same. We have a staging or testing environment where we will test our model. Here we have additional actors called prompt testers or human in the loop, because the nature of large language models is a bit different. Yeah, they hallucinate quite a lot, and also there are subjective metrics for like large language models tasks. Yeah, it's pretty hard to, let's say, to rate the text that was produced, right? For one person, it may be good to answer the specific question, and for a different person, the same answer may not be satisfying. So here we add a human in the loop. For very critical and important projects, we would have someone to look at these results, validate that the model is good enough, and then we move it to production, and we can sell it as an API. We can deploy it as an API for our clients, and things like that. So it's ready to be used. So this is briefly, this is how LLMOps would look like with Amazon SageMaker. And everything starts with a notebook. As you can see, not many changed. So we will have a lot of Jupyter notebooks still, even though we are shifting from classic machine learning to generative AI. We will have a lot of notebooks, and MLOps, LLMOps guys will always have to clean up the fire. And coming back to important topics, so as I said, I will compare and I will share about the new ways of working with generative AI models, with large language models, and we need to. And I would like you to understand the difference between prompt engineering and fine tuning in this case, because this is a new term for generative AI for foundational models called prompt engineering. This is another or a bit simpler way on how to work with generative AI models to get it to perform the task that you wanted to perform. And what I mean here, you know that these are you all know about ChatGPT, right? And we can ask it to provide us with the answer for any question, right? For any task, and how is the best to do it. Usually, we can ask it to summarize, we can ask it to classify, right? And basically, we can use some techniques called one-shot or few-shot learning, where we provide examples. And these examples are prompts. We can have a system prompt where we basically give like a high-level description of what we want to achieve, or what we want this model to do for us. Let's say you are a like movie review sentiment classifier model, and then you provide several examples. So this review, first review is a positive review, second review is a negative review, and then you provide a new review without the classification, and the model will be able to provide you with a proper answer, most probably if those reviews are like not super specific, or not super, based on some language that is specific to some, I don't know, region, some specifics that were not included in this huge data sets that large language models were trained on. So in this case, prompt engineering will not solve the task for us. It's a very powerful technique, and it's always recommended to start with prompt engineering before going into fine-tuning. But fine-tuning is another powerful approach, and it's more complex, but it can help you get more accurate results out of generative AI models. So one of the examples could be, for example, when you have a financial systems where you have a lot of financial terms, and you have your company is working with some specific type of companies, and they have a lot of abbreviations. They have a lot of specific like language that is not that known. So in this case, prompt engineering will not bring you good results, and you need to go into fine-tuning. And how the fine-tuning works? You need to collect a set of data, and in the case of fine-tuning of large language models, you don't need to have a huge amount of data, but it should cover most of the cases of all of these specifics that you want your model to know. And then you fine-tune, or you retrain this base pre-trained foundational large language model on this data. And after that, it can perform, it will know about this terminology, it will know all the specifics, and it can perform and answer your questions much better compared if it wasn't fine-tuned. So this is how prompt engineering and fine-tuning works. And a bit more details about fine-tuning, because it also changed. Previously, all the data scientists know, right? When we were fine-tuning, deep learning models, for example, we had to remove the last layer and change the size of this last layer to be able to perform what we want. So let's say we had an image classification model, and this image classification model was trained on 1,000 classes, and we want it to, for us, we just needed to predict 4 classes. So we need to remove this last layer and specify that it will only provide 4 classes, 4 answers. And then we have our custom data set that we prepared, and we train the model on it. In this case, it differs a bit with large language and generative AI models. There are different fine-tuning techniques. Some of them are based on reinforcement learning. Some of them are based on human in the loop, but they also require a lot of resources and a lot of people involved. And one of the easiest but also very powerful fine-tuning techniques is called parameter-efficient fine-tuning with LoRa adapters, or QLoRa, quantized LoRa adapters. that you can use to fine-tune your model. And the difference here is that we don't remove any layers from our base model, from our from the model that we want to train on our data. We just add an adapter to it. So what does it mean? Usually it works like it takes the output of the base model and it learns based on your data how to transform this output of the base model into something you want. And your data is learned here. And basically how the loop works, right? You have a loss function, so you check if the reply is like satisfies you, if how much it similar to the examples that you provide in the custom data set. And once you reach the point where you are happy with the result, there is a step where you merge those the adapter with the base model weights, and as a result you get a fine-tuned model, which is a single model, but it will be already trained on your data, and it will be able to perform the task you want and know all the specifics and terms that you wanted it to learn. So this is how parameter efficient fine-tuning works briefly. And I hope you are not feeling like this lady right now, and you don't get some weird requests from the boss like her, because everyone is super excited about generative AI, large language models. So be patient. And let's go into examples right now. So on the screen, you can see the very simple architecture. It doesn't have the split into, multiple accounts, multiple environments. So here we have like a single environment, let's say, but with all the required components to satisfy the machine learning lifecycle for the large language model. So let's say our task is to fine-tune this model, because the basic model cannot perform what we want. It doesn't know all the specifics of our data and how we can achieve that. So CI/CD and the infrastructure as a code, right? It's very important. I won't talk about it much. So usually we will have some place where we put our data set, where we put this custom data set to perform parameter efficient fine-tuning on it. If we want to have a full automation, we would have some triggers that are based on the events. So once we put the data inside this bucket, we will trigger our parameter efficient fine-tuning job, our training job. And in this case, we are taking the model from Hugging Face Model Hub, because this is a hub where we have biggest number of open source large language models. We can freely use most of them, and we can take them and fine-tune them for our tasks. It's worth to mention that Amazon SageMaker also provides the SageMaker Jumpstart, which can be used instead of a Hugging Face Model Hub in this architecture. So we take this model, we fine-tune it on our data, we track our experiments and our metrics using MLflow server. We could also use SageMaker experiments in this case, but MLflow server, MLflow tracking is super popular in the market. So MLflow will be the choice here. And after we are sure that our model is trained, after we get the proper results and the loss satisfies us, we will publish this model to the model registry. And once the new model, so if it's first time, then we will automatically deploy it to the SageMaker endpoint, or we can keep it in model registry and build some batch processing jobs based on that. But for LLMs, you want to have it as an APIs, so we will deploy it as a SageMaker endpoint. And if we already had a previous model, then we will have some approval step. We approve the new model, and it will be deployed to the SageMaker endpoint and replace the previous model. And once we have the SageMaker endpoint, we can consume it using like Python SageMaker SDK, or we can build LangChain applications based on that. So LangChain is a framework, is a Python framework that helps you to build applications on top of large language models. So this is pretty simple but very powerful approach that allows you to fine-tune your own large language models and make sure that they perform tasks on your custom data very well. To summarize, I wanted to provide some of the resources, very important resources. So there is a very nice SageMaker documentation, and it's not it's not so similar to AWS documentation. This documentation is written very well with a lot of details and examples. So please, if you're interested, go ahead and check it. There are examples how to fine-tune models. And also there are blog posts. Here I have a blog post from Philip Schmidt. This is a person from Hugging Face, which is working with AWS closely as well. And he provides amazing examples on how you can use large language models in Amazon. And also some of the examples of end-to-end pipelines with full automation using SageMaker pipelines, so that you can only drop a new data set and then the rest of the magic happens automatically. Some of the blog posts that I really like, and I personally recommend made with ML. This is more for machine learning engineers or MLOps engineers, but these guys also have some materials related to MLOps. This is more for coders. So here there are a lot of coding examples and practical examples on how you can use open source for ML. Practice on AWS. So AWS provides workshops and very packaged workshops where you can take some predefined code with placeholders for you to put some values or algorithms, and they teach you basically on how to use SageMaker and what are the capabilities of SageMaker. And SageMaker Immersion Day covers most of the capabilities that are available in this service. And operationalizing machine learning pipeline is more about moving models into production. So they don't talk about every service, but they talk about the main services that are needed in order to move your model into production. And these are the services that you've seen in those diagrams where I was comparing MLOps with LLMOps. And last but not least, this is a very huge recommendation from my side. The newsletters and the communities called Marvelous MLOps. So here you can learn a lot about MLOps tools, MLOps stories, different blog posts, and things like that. Swirl AI, it's a also great resource more for the architects or for those people who like diagrams, because the owner of this community draws one of the best diagrams in the world. And the Data Phoenix, it's also a great community where there are a lot of public free events that you can attend, but also all the different news from the world of AI, and very quickly shared with you. And I personally recommend to, if you're interested in the topic, I personally recommend to subscribe to 3 of them. And finally, so we are growing. As I mentioned, we have a lot of expertise, and right now we are looking for engineers, and including MLOps engineer. But also, if you scan this QR code, you will be redirected to our careers webpage, and there you will see different roles, including solution architects, DevOps engineers, and, as I said, MLOps engineers. So I hope this session was useful for you. I hope it was interesting. It was foundational presentation. We didn't dive deep into technology yet, but also, if you are interested, on our website there is a community page where we share our different webcasts, and there are webcasts for different technological levels. So now it's time for your questions, and don't forget about the prizes and the presents that we share. So let's see the Q&A section. I will answer one by one, but also feel free to raise the hand and I can unmute you and we can discuss some details if you are interested. So the first question, how do you integrate ML model training and deployment into existing CI/CD pipelines? And what best practice ensures seamless integration and reproducibility? It's a great question. And to be honest, existing CI/CD pipelines are more or less unchanged. Yes, they do a different task, but so the tooling there is very similar. We can use Amazon stack for that, like code deploy and code pipelines in order to build the deploy infrastructure that is needed for the models, but also the SageMaker pipeline. What is new here? It's a SageMaker pipeline. So SageMaker pipeline, you can think of alternative could be a Kubeflow or alternative could be an Airflow, where you split all the stages. Yes, where you split all the stages of machine learning training cycle and you automate them. Meaning that you take an input and output of one stage goes to as an input to the next stage until your model is trained, evaluated, and registered. So, but this is stored as a code, and basically once you change the code, your CI/CD pipeline will update your pipeline, and the pipeline itself, ML pipeline, right? So there is a different term here. CI/CD pipeline will update your ML pipeline. It won't run it, and in order to run it, you need to update the data or start it, for example, regularly, like on a daily basis, on a weekly basis, and up to you. Next question. What strategies and tools do you use for monitoring and observability of deployed ML models, especially for tracking model performance and data drift in production? Great question. And so Amazon SageMaker provides a service called SageMaker Clarify. And in resources of this presentation, there is actually a link to this service. And this service is very good because it allows you to do the explainability, the drift detection, and also it provides features for assessing large language models quality as well. So it's the service that is can be used both for MLOps and LLMOps, but there are also additional services, like let's say for the data drift and model drift, there is a open source tool called Evidently. This tool is great because it's not only allowing you to calculate all this data drift and model drift statistics, but it gives you ability to build great dashboards based on that and create alerts based on those dashboards. The next question, what tools do you use in your work and how often? It's a very broad question. I will try to answer maybe in having the mind the topic today's topic. So for LLMOps, it's when you want to be able to control your machine learning lifecycle. So I would say that serverless tools don't apply here, but we also use serverless tools like Amazon Bedrock. In this case, for LLMOps, we would focus on tools like SageMaker, first of all, Hugging Face Model Hub. So Hugging Face Model Hub, it's not a tool, right? They have Python frameworks that allow you to connect to Model Hub, download the model, train it, and also then use it for production. What is cool there that they have an integration with Amazon SageMaker, so you don't have to write a lot of code. You can import classes from Hugging Face and create trainings on Amazon SageMaker. For the model quality, I already answered. For the model tracking and evaluation of model tracking and experiment tracking, we often use MLflow. I think this is the tool of a choice for us, but also we use ClearML sometimes for some of the clients. Can be 1DB or weights and biases, but those two are the main ones. And for the deployment, as I said, it's mainly SageMaker endpoints, or there are different ways of different endpoints types. It can be asynchronous endpoints, can be synchronous real-time endpoints, but also those models can be deployed on Kubernetes. So this is a very broad question that took some time, but I hope I answered your question. What problems most often arise during model deployment? Model deployment, if the model training is made well, what do I mean? If this Jupyter notebooks or unoptimized work from data scientists is optimized well by machine learning engineers and MLOps engineers, then the deployment part isn't that of a challenge. I would say that the most important part is to make sure that your model is of a good quality and also it can perform as you expect, meaning it can perform like real time, or it can you have enough infrastructure to host it. You need to perform the stress testing. So this, I believe, is the most challenging part, and very often there will be issues there. Next question. I am interested in understanding the main challenges customers face when approaching MLOps and LLMOps. Could you elaborate on the specific aspects they encounter in adopting and integrating these practices? Very nice question. Most of the customers that we are working with, they already have an idea, they already have a model, and they are at the stage of the when I was sharing the slide of a machine learning lifecycle on AWS, they are at the stage where they have a notebook or they have a Python code which is unoptimized. They already chose the model architecture, but for them it's a big challenge to move this into production. And those challenges are very broad because they include DevOps challenges and also ML related challenges. So we help them optimize those models. We help them decouple those models, automate model training and model deployment phases so that they can use those models for their customers. And it's very often similar for those companies that train their own machine learning models or those companies that train their own large language models. There is another very popular problem that we are helping our customers to solve, and I highly recommend you to look at our previous webcasts on our website where we talk about RAG. So we also help to our customers to achieve retrieval augmented generation. So in briefly, this is the technique that helps your model to operate on your data without being fine-tuned on it. So we try to help mostly in all of these challenges to our customers. Another question, do you prefer MLflow only for metrics and experiment, or it also production ready? What do you prefer more, MLflow plus ECS or Kubeflow plus EKS? A good technical question. I would say that also depends on the customer. So I personally prefer MLflow. I think it's a bit unfair to say that it's only for metrics and experiments, because in MLflow you can also version your environments. There is also a model registry capability that you can use. There are quite a lot of features that you can use, and also for the deployment. So basically, if you wrap your model with MLflow flavor, then there are predefined ways on how to deploy it to SageMaker, how to deploy it to Kubernetes. So I personally recommend MLflow, and I think it's very production ready. In this case, we need to find the balance between usage of MLflow and SageMaker. So we use SageMaker model registry because it's tightly connected with AWS, so we don't have to take model from somewhere else. So we use SageMaker model registry, but for experiments tracking, MLflow is, on my personal opinion, is better than SageMaker experiments. And about the second part of the question, MLflow plus ECS or Kubeflow plus EKS. If you are on EKS already, then I think second option, but Kubeflow has MLflow built in. So Kubeflow is not only a tool it's not an alternative to MLflow. Kubeflow is end-to-end platform that helps you also build pipelines from training to deployment on Kubernetes. So if you are already on Kubernetes, yes, Kubeflow. If you small team, you don't have Kubernetes, then the ECS plus MLflow will be a better choice, and for the rest, SageMaker. Do you mostly use AWS as a main platform for your customer MLOps projects? Do GCP Azure have a similar options, or AWS is a leader for MLOps functionality for now, and you choose it as a recommended option? Good question. On my opinion, but it's very personal opinion, AWS is a leader in MLOps because SageMaker is very powerful and very there are not so many bugs, I would say, compared to the other cloud providers. There are alternatives in both GCP and Azure. I can't talk much about GCP because I know GCP Vertex AI on very high level. So the platform is called Vertex AI. I know it on high level. I can't compare much with SageMaker. And in Azure, there is Azure ML. It's also a great tool. It provides very similar functionalities, as I mentioned, for the SageMaker. But I would say that for me personally, user experience and how the Python SDK works was more convenient and comfortable to use in SageMaker compared to Azure ML. What are essential metrics for ML models? So this fully depends on the task you're trying to solve. So for example, for classification, you will have something like a precision, recall, accuracy. You will have precision and recall are the most essential metrics for ML models overall because they are more they are pretty generic. They can be applied to different model architectures and model tasks, but there are more precise metrics. For example, for computer vision, you want to use mean average precision to see to check if the area of detected object is very similar to your training data. And for example, for text tasks, you want to use something like cosine or Levenshtein distance to see how much the text that your model produced will be similar to the text that you were training on. But there are many metrics, and the accuracy is also pretty generic metric. How do you address security and compliance challenges unique to MLOps, especially concerning data privacy, model integrity, and regulatory requirements? Yes, nowadays this topic becomes more and more important, more and more attention to it. And so security security. It's by using AWS best practices, we ensure that the data is secure. So all the kind of encryption, all the kind of networking that is limited. So we never expose anything publicly. We do everything inside virtual private networks. Then we connect through some private tunnels or VPN connections. Then compliance challenges unique to MLOps, it's another point. So we always must know what model is used for which customer. So something like a model registry helps there as well, because audit would like to know how you control your ML environment. Can you quickly react? Can you do the root cause analysis and things like model registry, and one of the features of model registry is called model explainability. So these features help to make sure compliance and regulatory requirements. So it's also all the products on AWS are based on AWS services. So we can use famous AWS services like Guard Duty, like AWS Config, and you could hear about Messi and many more. You could hear last webinar about a lot of them. So we stick to all these rules, and we try to make, when we go to production, we make sure that all of these compliance and regulatory requirements are met. How does the cost structure differ between MLOps and LLMOps in terms of training and inference costs? It differs a lot. It differs pretty much a lot because of the nature of LLMOps. Large language models are large. Yeah, they weigh a lot, so they take a lot of storage. The more of them you want to version, the storage, the more your storage grows. Then in order to train those models, you need more resources. So if we can say that we could train, some, let's say, object detection model on a single GPU in few hours, now we need a multiple GPU instance that costs 10 times more, and not for a few hours, but maybe for a few days, or in order to achieve the result. So I would say that LLMOps is much more costly, and in inference as well. There are new techniques. So because of the very expensive inference, there are the community and also the engineering world rethought a bit the inference, and now there are a lot of techniques like flash attention, like some additional serving methods, quantization, that help you to reduce your model size and use less resources to do the inference, but still it's much more expensive than ML. What is the most popular and common in production right now? MLflow, Kubeflow, Airflow. So once again, I cannot compare. So MLflow is not direct alternative to Kubeflow or Airflow. MLflow is very known. Like, I would say that most of the data scientists and ML engineers met with it on their journey. Kubeflow is a bit more specific to the companies or teams that have good DevOps experience, because it requires, so in order to have Kubeflow, you need someone to manage Kubernetes for you, to deploy Kubeflow for you, to make sure it's up and running all the time. So if you have if it's less popular because it's more complex to manage. Airflow is less complex to manage and easier to use, but it provides less capabilities. So I would say it always depends, but MLflow is the most popular out of these three tools. What is the way for initial model selection for further fine-tuning? How do I know that I have done a correct choice? Good question. And similarly to data science experimentation, right? You would choose something to start with, and then you evaluate it and see if the results are good or not. Basically, the good approach is to start with a small model. So I won't recommend always going with the biggest model, GPT-4o or Claude 3.5, and these models are really good and they can solve most of the problems, but they are expensive, right? So I usually I would recommend to try something like P3 model, P-3. It's an open source model, and Mixtral models which are much smaller, and if they can perform the task, then why pay more, right? And also there is a Hugging Face leaderboard, LLM leaderboard, and basically it's also a good starting point for you to see which model to choose for the start, because this leaderboard is based on many data sets, and these data sets cover a lot of different AI tasks, and it helps you to compare those models depending on your need. Yeah, after you choose the model, still it's very good to define your evaluation pipeline based on the metrics that are specifically interested for you, and still have few candidates and evaluate them based on that evaluation pipeline. What is the best place to store a model from the infrastructure standpoint? Model registry. Model registry, it's basically an interface over some storage with additional features. So in AWS, every model is stored on S3 bucket, even though you can access it from SageMaker user interface. You have some additional features like being able to see metrics parameters, approve, reject, versions. All of that is there, but you mostly pay for the storage, and the storage is the S3 bucket. The same for other cloud providers. It will be some object storage like blob storage, Google storage, and things like that. And the same for MLflow. When you set it up, you need to provide it. If you set it up on AWS, you need to provide it with S3 storage. Anything about on-prem deployment on clients, private servers? How is the industry moving towards it? Because I'm trying to do something similar where, due to security privacy concerns, I won't be able to run inference on my server. Yes, as I mentioned, probably for the very tight security regulations, you need to look at the edge deployments. Edge deployment, it's when you deploy your model on a specific device, and only this device will contain your model, and you can place it in a safe place, and then it can be used like very securely in very closed environments. In a client's private servers, so if private servers, I would say, it's the servers that still servers, right? So you can place them in private network, in private subnet in case of Amazon, and make sure that only the client can access it over VPN and no one else. So then it's also very secure. Do you use any services for feature store or process data for both cases, MLOps, LLMOps? Yes and no. So it also depends. If you only need one model based on this data, you can use a feature store. There is a SageMaker feature store, right? And there is also popular feature stores from Hopsworks or Feast. they are cool, but it's where you need to share features. It's very important. For example, when you have multiple data scientists working on the similar or same data, but for different models or different tasks, or you have a huge team that you have to exchange the data between each other, then the SageMaker feature store or any other feature store will be a really good choice. And for LLMOps, it's a bit simpler. You won't have so many features, so you will have text, expected input, expected output, and then you just tokenize it. So in this case, it will be rare, like a bit more rarely used compared to MLOps cases. Is it feasible at this point in time to invest in optimizing underlying infra usage? Yes. So compared to what actor in Gen AI you are, so if you are a consumer, then probably not. Yeah. So you basically take the API, and it doesn't matter your infrastructure resources. Mostly, you just send the payload, you get the response. So mainly internet network connection is important in that phase. For fine-tuners, it's really important. Fine-tuners don't want to waste a lot of money on the infrastructure. They don't have so much infrastructure as providers. So quantization is very important. There are cool libraries, and one of this is bits and bytes if you are interested. So you can apply different quantization to your models and make them use less infrastructure resources. And also like flash attention is another powerful technique that allows you to perform inference on also using less resources. What are the key challenges in scaling MLOps deployment? Scaling. So infrastructure is a challenge sometimes, right? Because you need to have enough infrastructure, and in AWS, if you need more than 10 GPUs, you actually need to provide evidence and explanation to AWS why you need them. But let's say the automation around scaling is pretty much solved, and it was solved before MLOps and LLMOps. So different auto-scaling techniques are available for SageMaker. There are SageMaker auto-scaling rules where you can define, so you want to scale your model like based on the number of active connections. So if you have many connections, another model will be deployed, and then users will be distributed between those models. You can have scheduled scaling. So for example, you know that on Black Friday, you will have much more users, and you already start 4 models on that day. You can automate that as well. In Kubernetes, also possible, there are cool autoscalers, and one of them is SCADA. You can define different metrics like GPU, CPU usage for both SageMaker and Kubernetes, and you can scale based on that. How security and compliance can be addressed? I think I partially answered the question. So by using secure cloud, by following generic security rules, and also there is even, if you know about OWASP, so there is a new paper from them about compliance and security in large language models. So, it's like DevSecOps, right? Now it will be MLSecOps, LLMSecOps. So you need to be aware and careful about security. You need to scan if you build in Docker images, you need to scan your images. You need to scan your code using dynamic or static security scanners. You need to put your model into secure environment, which is limited to only specific users. You need to apply very powerful authentication techniques so that no one can break into your model. And you need to have evidence of all of that. So, for example, in Amazon, there are services that help you address audit. So it's not much related to ML itself. I would say that privacy issues, okay, because some of the models were trained on, biased data, or some of the models were trained on some personal data, and by using the hallucinations, we can get some secure information out of that. So it's also, I never mentioned about this, by the way, it's also important to apply guardrails. So there are different guardrails, there are different libraries for that. There are in Amazon, there is Amazon Bedrock guardrails service. Then there in NVIDIA, there is Nemo guardrails, and also there is a Python guardrails AI library, and all of them are pretty good. So it's also important to apply them if you are using large language models. Based on your experience, what the takeaways you came to when it comes to cost optimization working with models? Cost optimization, again, model pruning. So for ML, when we train the model, and the same for LLMOps. For LLMs, when we train the model, we need a bigger architecture. We need some layers that are only important during the training. So when we are doing inference, we can do inference in the same architecture, but it will be a bit of waste of resources. So we can do model pruning, model optimization. We can convert models to the optimized model formats like ONNX or TensorRT. And we can serve those models effectively. For example, one GPU can usually fit, if we train the model, it can fit a single model, but the same GPU for the inference, it can fit, let's say, from 2 to 4 models of the same architecture for the inference. So we need to be mindful about this, about the GPU usage, about all of that, because GPU usage is something that is that has the biggest impact on the cost optimization. I think it's very important also to quantize models, as I mentioned, and apply all these known optimization and model pruning techniques in order to use your infrastructure resources efficiently, because infrastructure is still the most important piece. If you use serverless services like OpenAI or Amazon Bedrock, you need to be mindful of your token usage. So here you don't have resources. You will not pay for infrastructure resources. You will pay for tokens. So you need to look at if you are not over using them. You can also apply some prompt compression techniques that will reduce the size of the tokens that you are sending to the model. So I think these are the most important takeaways for the cost optimization that I have right now. There are no open questions in Q&A. So I hope it was a useful session. We will share the recording with you, and the recording will be shared publicly. And after the session, we will analyze the most active participants and provide the prizes, as we mentioned. And again, don't forget to visit our website, our previous webcasts, and our open positions. We are scaling, and we are always open to get great talent. So thank you very much, and have a great rest of the day.